Hey, everybody. Welcome to today's webinar. We have our guest today who is John Turner. And if you're here, you probably know what today's topic is. It's the Absolute Beginner's Guide to Docker. So, hi, John. Thank you for coming today.
Hi, thanks for having me here.
Yep. And, before we get started and before I give you the stage, just go through some housekeeping things. Uh, I know a lot of people are going to ask this question, but today's talk is recorded and will be available on our YouTube channel. So be sure to head over to YouTube if you're not already there watching this. And be sure to like and subscribe this particular video and subscribe to this channel. If you want any particular news about JetBrains, Rider, ReSharper, be sure to follow our social media channels over on Twitter, where you'll see some of the upcoming webinars also promoted there. So other than that, John, thank you again, and I'm going to hand it over to you, and you can get started. Thank you.
All right, thank you, Khalid. Yeah, so welcome to this webinar on getting started with Docker. As Khalid mentioned, my name is John Turner. Just to get us started, I wanted to say a quick thank you to Martin and Khalid and the other folks at JetBrains for organizing this and putting it all together and inviting me to be here. I think it's super awesome that companies like JetBrains um, put on stuff like this to help people learn, even if it's not necessarily about the products that they develop and sell and stuff like that. I think that's super cool. I also wanted to say thank you to everyone who's attending this, those who are attending live and also who are watching the video afterwards. Learning new things can be super fun, but it can also be challenging sometimes. It can take work. And so thank you for being here and putting in some effort to learn something new and hopefully get better. And hopefully I'll be able to share some stuff with you that'll be useful for you. So speaking about me, I'm a software developer. I have been for almost 20 years, which makes me feel really old when I say that. But I currently work at a company called Immersion. We do online automated language proficiency evaluations. So a lot of our customers are like HR people who are hiring for positions that have certain language requirements, spoken or written language requirements. Think of like help desks, call centers, that kind of stuff, where you're hiring someone who maybe doesn't speak the language of the people that you'll be supporting, and you have to make sure that they speak the language well enough. Anyway, if that sounds interesting to you, go check out our website, or you can ask me about it later. Speaking of talking to me, the next couple links on here, I put my email address and my LinkedIn profile. We should have some time at the end for questions and stuff, so please feel free to ask questions as we're going along. But if for some reason your question doesn't get answered, or you have other questions later, or you just want to talk about Docker, feel free to message me. I don't usually talk about Docker a ton. I usually talk about other things like test-driven development and pair and mob programming and continuous delivery and stuff like that. So if you want to talk about any of those things, feel free to message me on those about those things as well. The fourth link there, I put my personal website there. I have a blog if you want to go read stuff that I wrote, or if you want to go look at weird retro ASCII based video games that I made, you can go look at that there too. And the last link is on here is a link to the slides. That link is, if you're watching this on YouTube, that link is in the description. But if you want to get to a copy of these slides, you can go to that link. I'll put this up at the end too. If right now you're like, well, I don't know, is this actually even any good? I'm not going to copy down the link yet. I don't know if this is any good. I'll put it up at the end too, so you don't have to decide right now. All right. So what are we actually going to talk about? We're going to talk about Docker today. That's why you're all here, right? Specifically today, we're going to talk about using Docker in a development environment. Let me tell you why we're going to talk about that. So I've been to some presentations about Docker where the narrative kind of went like, well, if you want to be a good developer, you have to do continuous delivery. And the only possible way to do continuous delivery is if you have a microservices architecture. And the only possible way to do a microservices architecture is to use Docker, right? So if you want to be a good developer, have to use Docker. I don't like that narrative for a couple of reasons. One is because, while I'm an advocate of deploying value to your customers frequently, continuous delivery maybe isn't appropriate in every context. Certainly, while a microservices architecture can be a great way to deploy to your customers frequently, it's not the only way. And definitely while Docker or other containerized solutions can be a great way to do a microservices architecture, it's not the only way. So there's sort of a false equivalency there, which I don't really like. The other part of that I don't like is sort of the implication that in order to get any value out of Docker, you have to rewrite your entire application so that it's microservices and containerized and all that sort of stuff. And in my experience, at least anyway, then I found that there's a lot that you can get a lot of value out of Docker without having to put in, this multi-year effort to rewrite your whole architecture and redo your whole code base and everything. And so specifically, I've found a lot of value in using Docker in a development environment. I found the barrier to entry there is way lower. Like you can in a few minutes or an hour or something, you can start doing some things with Docker in a development environment instead of having to spend, like I said, multiple years rewriting your code potentially. Yeah. So that's why we're going to talk about using Docker in development. You can totally use Docker in a production environment, and there's lots of topics there. We're not going to talk about those today. Not because they're not important, just because that's not what we're focusing on today. Okay, so if you want to get started with Docker, a great place to start would be to actually install Docker. The Docker is a little inconsistent on the actual naming of the installable thing. Sometimes they call it Docker Desktop. Sometimes they call it Docker for Windows or Docker for Mac. Sometimes they call it Docker Desktop for Windows or Docker Desktop for Mac. So they used to call it Docker Community Edition. I don't know if they call it that anymore. But for Windows and Mac, there is an installer, a file you can download to install Docker. If you're running Linux as your dev environment, you probably already know about all this. But if you don't, there's probably an installation process for Docker using your distro's package management system, probably. Just go do a search for it. But if I'm assuming most people will probably be on Windows or Mac. And for that, there's an installer for Docker Desktop. So when you install Docker Desktop, what do you get? You get a few things. Let me show you real quick. One of the things you get is, on Windows anyway, you get this little system tray icon. On Mac, it's up at the top. That you can click on this and you can start to interact with Docker a little bit. You can see you get this cool UI here. This is one of the things that you get. We won't talk a ton about this right here, but that is a thing you get, and it's a way to know that you've installed Docker properly and that it's working and all that sort of good stuff. So you get that UI. On Linux, you don't get that, but on Windows and Mac, you do. Another thing you get on Windows and Mac is it will install a Linux VM for you. That's how the Docker containers will run. We'll talk more about that in just a few minutes. And then you also get some command line tools. That's mostly what we'll be talking about today. If the term command line tools makes you like scary because you're not a command line person, know that there are some GUI tools for interacting with Docker as well. I'm not going to be talking about those much today because I'm for a couple of reasons. One, because I'm more familiar with the command line tools. Also, all the things you can do with Docker, you can do in the command line tools. Depending on the GUI tool, you may or may not be able to do all the same things. And then also even if you choose to use some sort of GUI tool for interacting primarily with Docker, the ideas that we'll talk about will still transfer to those GUI tools as well. But like I showed you, Docker itself has some GUI tools. This is a JetBrains webinar, so I'll mention the fact that Writer has some Docker tooling built into it as well. Many other IDEs do as well. Visual Studio Code. Yeah. So, all right. So installing Docker, go install Docker Desktop. Once you have installed Docker Desktop, then you can run containers. Yay! Now you may be asking yourself, well, what's a container? And if you ask yourself that, thank you, because that's what I'm going to talk about next. So I'm going to assume that most people are familiar with the idea of a virtual machine, a VM. If you're maybe a little less familiar with it, the idea is this is an oversimplification, but you can think of it this way as a piece of software that runs on a physical computer, and that software pretends to be another computer. So like it will oftentimes emulate hardware. Typically you'll run a full operating system on that emulated hardware, and then you can run programs on that operating system that's running on that emulated hardware. So a container is not the same thing as a VM, but you can think of it kind of like a VM. If you've worked much with VMs, you're probably familiar with them, taking a lot of system resources, taking a lot of storage space, being, slow to start up. Everything's kind of sluggish. Containers typically are not that way. Containers don't emulate hardware, and they don't run their own operating system kernel. They require an already existing operating system kernel running somewhere to work. So containers are usually a lot smaller storage size-wise than VMs. A lot of times they'll be less, computationally resource intensive, and they typically start much, much faster than a VM. So containers, they're not a VM, but they're like a VM. You can think of them like a VM. Okay, another term that you will hear with Docker is, in addition to Docker containers, you'll hear about Docker images. What's the difference between a container versus an image? Again, containers are not VMs, but think of a VM for a minute. Somewhere with a VM, somewhere on disk, you'll have a file, or depending on your virtualization technology, maybe a couple files that represent that virtual machine. You have some actual files on disk, right? And from those files, you can create a virtual machine instance, right? Or you can potentially create multiple virtual machine instances. Like I can have one file on disk. I could create 3 virtual machines using that file, right? With a Docker image, the same kind of thing. A Docker image is actual files on disk that have the bits that will execute and some metadata about the image and stuff like that. And then from that image on disk, you can create multiple containers if you want. So that's sort of the relationship between containers and images. We'll talk a little bit more about images in a minute, but that sort of gives you a brief introduction. I wanted to talk briefly about there are different types of containers. If you go and look on the internet searching for information about Docker, 95+% of it will be for Linux containers. There are also Windows containers though. So in order for these containers to run, as I mentioned a minute ago, it has to have a compatible operating system kernel already running. So in the case of Linux containers, you have to have a Linux kernel running. That's why on Windows and Mac, when you install Docker Desktop, it will install a Linux VM for you. So you can it's a stripped down, lightweight Linux VM, but that's so you can have a Linux container, a Linux kernel, running that your containers can then use. On if you install Docker on Linux, you already have a Linux kernel, so you don't have to install, it doesn't install a VM. It uses your already existing Linux kernel with all of your containers. The same thing is true of Windows containers. You have to have a Windows kernel. So to my knowledge, at least anyway, you can only run Windows containers on Windows. Like I said, it's not nearly as common as Linux containers, but they do exist. It is like, full-blown Windows. So you can run things like legacy .NET framework code or applications in IIS or Windows services, things like that. So if being able to run those types of things in an isolated container sounds cool to you, go look up Windows containers. But for the rest of this presentation, we'll be talking about Linux containers. The examples I'm going to use are all Linux containers. A lot of the concepts and stuff would apply to Windows containers as well, but we'll be talking about Linux containers. Okay, so that's sort of a brief whirlwind introduction about Docker. Let's go actually do some Docker stuff. So I'm going to come over here to my terminal. And so as I mentioned, when you install Docker Desktop, you get a couple things. You get the little system tray UI thing. You get a Linux VM, which for the most part, you don't really have to worry about. Sometimes it's nice to know that it's there. And then you also get some command line tools. And the installation setup should set it up so that those command line tools are in your path. It installs several command line tools. The primary one, and the one we'll be talking almost exclusively about today, is the Docker command, aptly named. So there's an actual file on my disk somewhere. I'm on Windows, so the actual file that I have is called docker.exe. On Linux or Mac, it'll just be an executable file named Docker. This is your gateway to most of the common Docker functionality, right? Like I said, there are other tools as well, but this is the main one. This allows you to run Docker containers. Let me show you what that looks like. This Docker executable, it is a command line interface tool. So there are different commands that you can send to this Docker executable. The one we're going to talk about right now is the run command, aptly named, if you want to run a container. So you say Docker run, and then you tell it the name of an image that you want your container to be based off of. I happen to know that there is a hello world container out there somewhere, image out there that I can make containers out of. So what this does, when I hit enter, what Docker will do is it will first look on my local machine and say, hey, is there an image here named hello world that I can use to start up this container? If there is, it will just use that image that you have locally, and it'll spin up your container, and you're good to go. In my case, to avoid the vagaries of internetness while doing a presentation, I already have all of the images that I'm going to use downloaded to my local machine. So if you go and follow along with these examples, the first time you do it, you'll see a little bit of additional output. But then after that, it should look the same. So if you have the image locally on your machine, Docker will just use it to create a new container. If you don't have it, Docker will go look at it'll go look at an image registry. And the default image registry for Docker is called Docker Hub. It's sort of the NPM package manager, but for Docker images. That's the default one, is Docker Hub. You can set up Docker to look at other registries, or you can have your own private registries if you want. But you get Docker Hub by default. So Docker will go, again, by default, look at Docker Hub and say, hey, is there a hello world image on Docker Hub or whatever other registries you have set up? If there is, Docker will download that image from the registry to your local machine and then run the container. So that's a little bit more about how Docker images work. So let's see this actually run. So if I hit enter, I get some output. Yay. So if you've never done anything with Docker before, congratulations, you just saw your first Docker container running. In this presentation, we're going to talk about three different types of containers that you can use in a development environment. This first kind is a container that spins up and does a thing and then stops. In this case, all it did was that my container, it spun up and it printed out some text and then it stopped. I'm using this terminology, a Docker container starting up or spinning up and then stopping. Let's talk just a little bit more about the life cycle of containers for a minute. So when I do that this Docker run command up here, that will create a new container and it will start it, and then the container can do whatever the container is supposed to do. And then it will stop. But how do you see the current state of your containers? There is another Docker command called Docker PS. PS was originally a Linux command. It stands for process status, I think. That's not super important for this, but just know if you want to see a list of your containers that are currently on your system, do Docker PS, and you'll notice I have no containers. I just have some headers there. Unfortunately, I don't know why they did this, but the default for when you do a Docker PS command, it will only show you the containers that are currently running. To see all of your containers, you need to do Docker PS-A. And this will show you all of the containers that are on your machine, regardless of the state. So if I do Docker PS-A, you can see I do actually have a container here. Its status is that it exited about 2 minutes ago. It was created about 2 minutes ago. It was based off of the hello world image. A couple other interesting things, every container gets an ID, which is kind of like a hash. You can use it there's some of the commands that you can use with the Docker executable where you have to tell it which container you want to execute that command on. You can use the container ID to specify which container you want to run on. The nice thing about the ID is you don't have to type out the whole ID. You can just type out enough of it so that it disambiguates from the other containers that you have. So usually 2 or 3 characters is more than sufficient. Containers also have a name, which you can see over here. You can explicitly name your containers if you want to. If you don't, then Docker will generate a random name for you, which fortunately this one is not embarrassing or anything. So that's good. Now, if I don't do anything, this Docker container that I have here, it's in a stopped state. It's not doing anything. It's not running anything. If I don't do anything, it will just sit here forever. Now, if you're like me and sometimes a little bit of a neat freak, you're like, well, I'm not going to run this container again. I'm not going to do anything with it. I just want it to go away. Don't stop being here and cluttering things up. You can do that. There's a Docker command called Docker RM for remove. So this tells Docker to remove the container, and then you have to tell it which container. So I could do the name of the container over here, or I could do enough of the ID to be unique, right? So I can probably just do a couple characters. So this says remove the Docker container whose ID starts with 2F. And then you can see that container is actually gone. So now it no longer exists on my machine. Now it's a little bit cumbersome to like run Docker containers and then have to do this Docker PS-A all the time to see what's actually still on your system and stuff. So fortunately, Docker has a shortcut to remove a stopped container. When you run a container, you do --rm, which also stands for remove. This will make it so that when the container stops, it automatically gets removed. So if I do Docker run --rm hello world, then you can see I still get the same output that I got before. But if I do a Docker PS-A, you can see Docker has automatically removed that container after it stopped. So with the --rm, the Docker will spin up a container, the container can do its thing, the container will stop, and then Docker will automatically clean it up for you. So in most of the rest of the examples we do here, you'll see me do a --rm when I run a container. So again, this is the first class of containers we're going to talk about that you can use in a development environment. That is containers that that spin up and do a thing and then go away. This example, it just prints out text. You can have more interesting examples, like you could have a container that runs some calculation or run some tool or something like that. We'll see an example of that in a little bit. Or you can just have something that, oops, if I can type. Or you can, have a Docker container that runs Nyancat, which is pretty cool. So that's the first class of a Docker container we're going to talk about. The second class that we're going to talk about is not containers that spin up and do a thing and go away, but containers that spin up and run some service indefinitely and just sort of sit off on the side in the background, running some service. Now here, when I'm talking about service, I'm talking about think of things like a database or a message bus or a web server, something like that. So let's see an example of that. I'm going to run a new container. I'm going to have it automatically get removed, and I'm going to run Nginx. If you're not familiar with it, Nginx is a popular, fairly common open source web server. I'm now running Nginx. I'm running a web server, and you can see it's output some stuff here about how it's running. That's pretty cool. Currently, though, I can't really interact with this web server a lot. Like I can't. It'll be a little bit challenging for me to interact with it because of how I have run it. So I'm gonna stop it and I'm gonna rerun it in a different way that makes it easier for me to interact with. If we go back to the idea of containers versus VMs again for just a second, remember a container's not a VM, but you can think of it kind of like a VM. So inside of a container, one of the things that a container has inside of it is it has network ports, just like a normal real computer. And you can have things that run inside that container combined to those network ports. But by default, the container is isolated. So you can't connect to those network ports from outside of the container. Nginx, it's a web server, so it binds to port 80 by default, but it binds to port 80 inside the container, and there's not a way for me to really access that from outside the container. So I'm gonna show you how to run it so that you can access that. Docker has a nice built-in way to do that. Another thing I wanted to show you is some containers, when you run them, will respond to if you want to stop the process that's running inside that container, you can do a Control-C. I'm doing Control-C right now, and you'll notice that Nginx is not stopping. Nginx is not one of the types of containers that responds to Control-C. I think it used to, but it doesn't anymore, which makes me sad. So there is a way in Docker to stop a container, but since this terminal session here is taken up, like it didn't give me control back, I'm going to go over here to this other terminal session. You can see I can list my containers. That Nginx container is still running, but I want it to stop now. So I can explicitly tell it to stop, and I have to tell it which container. So I'm going to give the first two characters of the ID. And you can see now it is stopped. And because I launched it with a --rm, Docker said, oh, this container stopped, so I'll automatically clean it up. And if I come back over here to my first terminal, you can see it gave me back control of the terminal, and it also printed out some stuff about how it, when it was shutting down. So let me show you how to run this, but in a way that I can interact better with it. Remember, we talked about ports, networking ports. Inside the container, Nginx will bind to port 80. Docker allows me an easy way to map a port on my local machine, my local host machine, to a port inside a container when I run it. The way you do that is with a -p, stands for port, and then you tell it the port, your local machine port that you want to map to. I'm going to say 8080 because I know that there's nothing running on 8080 on my machine. And I'm going to map that to port 80 inside the container. And then I tell it the name of the image that I want to run, Nginx again. And so now I'm running just like I was before. But now if I come over here, I can do whoops, we'll do an HTTP GET for localhost on port 8080. Remember, that's the port on my local machine that I bound to. And if I get the body of that, you can see, hey, look, I am now running Nginx. And if we come back over here, you can see Nginx, it printed out some stuff. It said, hey, somebody issued a GET at the root URL. They asked for HTTP1. I returned to 200. Here's what their user agent string was, blah, blah, blah. So Nginx really did serve up that text that said Nginx. It's not. I'm not nothing up my sleeves. So yeah. So let me come back over here, and I will stop this one. Let's do another example really quick. Okay. So Nginx is stopped. That container got cleaned up. Let's run another example. Let's also do with this one. You notice when I ran Nginx, it took over my terminal, and if I wanted to go do something, if I wanted to do something else, I had to go to a different terminal. Sometimes, especially with these service type containers, you just want them to like start running their thing and go off and sit in a corner. And if you want it to stop or interact with it or something, you'll do it. But you just want it to just go off in your corner and run and give me back access to my terminal. There's a way to do that. You do that with a -D. That stands for detached mode. So this will start up a container and give you back control of your terminal. I'm going to do a -P again. I'm going to do a different port though this time because I'm running 7.2. I'm going to run a different thing. I'm going to run RabbitMQ. If you're not familiar with RabbitMQ, it's a message broker. And I am now running RabbitMQ. And you'll notice because I did the -D, it gave me back control of my terminal. So now I can do stuff here. But Rabbit is still running inside a Docker container off on the side somewhere and can do stuff. So if I do a localhost 15672, if I do an HTTP request there and get the body of it, you can see it is running the RabbitMQ management portal. Often, not every time, but oftentimes these containers that run a service, they will have their own web server built in, and you can interact with them through a web browser. Rabbit is an example of that. Speaking of these, of interacting with these tools, let's see. Let's turn this one off. Rabbit is a little bit slow to shut down, but we'll get there eventually. Speaking of interacting with these services, one of the nice things about some of these Docker containers is sometimes you want some tooling to be able to interact with these services. So, for example, say you have a database, you might want a tool so that you can interact with the database and create schema and run queries and all that sort of stuff. Sometimes these containers have some of those tools built into the container itself. So I'm going to do another example. I'm going to use Postgres. If you're not familiar with Postgres, it's an open source relational database akin to MySQL or SQL Server or Oracle or something like that. And it has there's a Docker container for Postgres. You can run your database in Postgres. It also has some of the tools needed to interact with it built into the container. So there's a command line tool called pSQL that lets you connect to a Postgres instance and create schema and run queries and stuff like that. So I'm going to show you how to both run Postgres in a container and run that tool in the container as well. So let's start with running Postgres. So I'm going to do --rm so when this container stops, it'll go away. I'm going to do -D for detached. And then this is true in Windows and Mac, but probably more so on Linux. Sometimes for some tools and some services, one of the ways to configure them is with environment variables. You can have an environment, it's just like a key value pair sort of thing. So you can have a named environment variable and set its value. That's pretty common in the Docker world for how to tell a Docker container to start up and be configured and all that sort of stuff. Docker provides a really easy way to set environment variables when you start a new container. You do that with a -E. This Postgres image happens to require an environment variable to actually start up. It wants to know how you want to do your authentication. Let's see, and that is, so I have to set this environment variable in order for this container to start up. So I'm going to set, here's the name of my environment variable, whoops, and here's its value. This is just saying, hey, it's okay to trust anybody that connects to this database. You wouldn't want to do this in production, but since this Postgres instance is only going to live like 3 minutes, then it's probably fine. Okay, so I'm now running Postgres. All right, but we want to be able to interact with this this Postgres instance. So let's go see how to use that psql command line tool to connect to this Postgres instance and do stuff. Now I could I could have that psql executable on my local machine or some other tool that interacts with Postgres. I can have it on my local machine and interact with Postgres that way. I would have a little bit of a problem how I've launched this one because I haven't mapped a port in here. I need to map a port as well. But I could do that if I set up the ports correctly. But I'm going to show you how to run a command inside the container just as an example. So to start a new container, you do docker run like we did up here. To run a command inside an already running container, you do docker exec. We're going to do docker exec. If you just want to execute a command inside that container and get its output, you can just do docker exec and which container you want and what command you want to run. However, if you want to interact with that command, like type something and get output and type some other stuff and get some more output, if you want to do it in a more interactive way, you have to do -IT. That stands for interactive GTY terminal. Just know that if you want to interact with a command that you're running in a Docker container, you have to do -IT. Then we need to tell which container we want to run this command in. Again, I'm going to use the ID, just enough of the ID so that it disambiguates. And then I have to tell it what command I want to run. Now I could just directly run psql here, but I want to show you a couple other things. So I'm going to run something else. A lot of times in these containers, in addition to having whatever service they're running, like Postgres, and whatever and tools to interact with that service, like psql, they will also often have a shell, like bash. So I'm now running bash inside the container that is also running Postgres. So again, the container is not a VM, and I didn't just SSH into the VM, but you can think about it like it's a VM and that I just SSH'd into the VM. So here I'm running bash inside that container. It's a Linux container. I can go look at the file system inside that container. I can, CD over here into Etsy and come and look in here and go play with systemd stuff if I want to. It's a Linux system, right? I can go and do all my Linuxy stuff, all my normal bash stuff, because I'm just running bash inside Linux. It just happens to be in a container. But the thing we want to run here is psql. So if I do, so you can see I have psql here inside this container. So I'm going to run it, and I'm going to connect to the Postgres instance that is also running inside this container. By default on psql, it will try to connect to localhost. But since I'm running the pSQL inside the container where Postgres is also running, then Postgres is running on localhost from the perspective of pSQL, right? I do need to give it a name here, a username, but I'm now running pSQL inside the Docker container that is also running Postgres, connected to Postgres that is running inside that container. So I can do a /DT, I think that stands for describe tables. You can see it didn't find any tables because this is a brand new Postgres instance. I haven't created any tables or any schema or anything like that. I can say create table, my table, something like this. I can create a primary key. It's a varchar in case you want to make it a GUID or something. I don't know. Don't judge me. I'm not a DBA. I can make an integer column and a string column with the varchar. If I typed it right, I did. Good. You can see I now have a table called my table, and I can do selects from it. Oops. I could insert new rows into that table, but then you have to watch me write insert statements, and probably nobody wants to do that. But you can see it's a full database, and I can interact with it, create schema, run queries, all that good stuff. And the cool thing is that both the database and the tools to interact with it are in the same Docker container. Okay, so I'm here. I'm running pSQL. I'm going to exit pSQL, running in the container, back to Bash, running in the container, and I'm going to exit Bash, running in the container, back to PowerShell, running on my host machine. Hopefully that wasn't too inception-y for everyone. And then I'm going to go and stop that one because we don't need that anymore. All right, now you may have been thinking to yourself, okay, this is cool. I can run a database or something, or Rabbit or a web message broker or a web server or something like that inside a Docker container, but it's kind of cumbersome to have to remember that whole command to type out every time I want to run my database to do my local development. Wouldn't it be nice if there was like some nice, simple, easy way that I could just say, run the stuff I need? Well, if you ask yourself that, thank you for asking yourself that, because that's what we're going to talk about next. We're going to talk about a thing called Docker Compose. So we mentioned that when you install Docker Desktop, you get a couple things. One of the things you get is some command line tools. We've talked about one so far, right? Docker, or on Windows, it's docker.exe. Another tool you get is Docker Compose. Now, Docker Compose used to be a separate executable. In fact, it's still installed as a separate executable. It's docker-compose. On Windows, it's docker-compose.exe, technically. But recently, within the last year or so, then they added Docker Compose functionality to the docker.exe executable. So now instead of doing docker-compose, you can do docker space compose. Mostly I tell you this so that if you go and look for Docker Compose examples on the internet and you see Docker dash, in some places you see Docker dash compose, and in some places you see Docker space compose. That's what the difference is. You used to have to use the Docker dash compose executable, but just recently they made it so you can use Docker space compose using the Docker executable. Okay, so let me go show you, before we actually run this, you'll notice in this directory I have a docker compose.yaml file. Let's come over here into Writer, and I can show you what this looks like. Docker Compose lets you spin up a bunch of Docker containers all at the same time. It calls them services. So what this Docker Compose file says is, I'm going to run some service called Redis. It happens to be based off of this image, also named Redis. These names don't have to match, but they can. For example, it's also going to spin up something called Rabbit that's based off of this image right here. Here you can see the service name and the image name don't match. They don't have to. If you remember when we did the port mapping thing from the ports on my local machine to the ports inside the container, when we did a Docker run command from the command line, we did a -p to do that. This is how you do that in Docker Compose. Here you can see with Redis, I'm mapping one of those ports. I'm keeping it the same port inside the container as outside the container. These could be different. Here I'm mapping multiple ports. You can also do that from the command line if you want to. Here, I'm going to run another service called Postgres. It's based on the Postgres image. This is just like how we did with the Docker run example a minute ago. Here's how you do the environment variable. If you wanted to map a port so you could interact with it using tools from your local machine, like if you wanted to install some UI that can interact and run queries against Postgres, you could do this. One of the things that I didn't mention when we were doing our Postgres example previously is that table that I created. I created a table, I could have inserted rows and all that sort of stuff. When that Docker container goes away, that table and any data in it also goes away. It's actually a little bit more complicated than that, but you can think of it as that file system that I was looking at inside my Postgres container. It's ephemeral, meaning when the container goes away, all of that file system and anything stored there also goes away. It's not exactly true, but it's more or less true. That's the default anyway, that when you create a container, that file system that goes along with it will go away when the container also goes away. You can tell Docker not to do that. You can tell it not to do that for specific directories inside the file system. This is how you do that in Docker Compose. You can say, hey, when I launch this Postgres container, this directory inside the file system, rather than having it be this ephemeral thing that goes away, actually persist it. Anything that gets written to that directory, persist that data and persist it in this thing called, it's called a volume. Persist it in this volume called Postgres data. That way, when this container goes away, any data that it's written to this directory will persist. So if you start a new container and have it set up the same way with the same volume, it will get the same data that the previous container had. That way, every day when you start up your dev machine and start up your Postgres container, you don't have to start from scratch and recreate all your schema and data and everything like that. And I just happen to know that this directory is where Postgres writes all of its schema and table data and all that sort of stuff too. If you go look at a container, at a Docker image in Docker Hub, usually they'll have documentation that says where it writes data, or sometimes you have to go to their GitHub page or something like that. But you can usually, if you want some data from that container to persist, you can usually go and find out where whatever's running in that container stores its data, so you can persist it like this. Okay, so this is a Docker Compose file. It's going to start up Redis, Rabbit, and Postgres. Let's go actually do that. So to run Docker Compose, you do Docker Compose. Remember, there's a difference between Docker Space Compose and Docker - Compose. We're going to use Docker Space Compose. To start up all the things, you do Docker Compose up, and you can hit Enter. And you can see it's creating a Postgres container, a Redis container, a Rabbit container. It's outputting stuff from all three containers. In this case, they happened to go in order. Sometimes they get messages from the different containers get interleaved. Here they happen to all be in order. That's not always necessarily true. And so now I'm running Postgres, Redis, and Rabbit all together. And if I want to close them, oh wow, I'm running all kinds of stuff here. If I want to close them, I can do Control C. You can see it's stopping all of those containers. If you remember back to our Docker run examples, if I just do a Docker run, then it will take over. Oh, Rabbit's taking a long time to stop. If I just do a Docker run, it will take over my terminal. Same thing with Docker Compose. If I just did a Docker Compose up, it took over my terminal. If I don't want it to take over my terminal, I can do, and I just want my stuff to run and go be off on the side, I can do a Docker Compose up -D, just like I did with Docker run. Again, D stands for detached mode. So if I do this, I now have Redis, Postgres, and Rabbit all running with one nice easy command. I can do a Docker PS, and you can see this is kind of ugly here because these containers have a bunch of available ports that they can map. So my console wrapping here is kind of ugly, but you can see I have three containers all running. Okay, so we've talked about two classes of Docker container that you can run in a development environment. The first one is the kind that you run it and it spins up and does a thing and goes away. We saw an example with like Hello World. The second type that we've talked about is a container that spins up and runs some service. We saw an example with Nginx and Rabbit and Postgres. Sometimes you can have tools that you need inside that container as well. And then we also talked a little bit about Docker Compose, which makes it easy to spin up a bunch of those services at once if you need to. If your code, on your local development machine, you need a database and a message broker and whatever else that you can run in Docker, you can spin all those things up at once. The third type of container that we're going to talk about today is a container that has development tools in it. So for example, let's say I want to write a Python program, right? But I don't have Python on my machine. And interestingly, Microsoft likes Python enough that if you just type Python, it'll open up the Microsoft store and give you the option to download Python. That's either cool or creepy. I'll let you decide. But I don't have Python on my machine. But I do have Docker, and I can run Python inside of Docker. So let's look at that. So if I do Docker run, I'm going to start a new container. I'm going to do --rm, so it'll go away when I'm done. I'm going to do -it again so I can interact with the command that I'm going to run inside the container. In the Docker Compose example, we saw how you could map, how you could make a directory inside the container persist. The way you do that from the command line is with a -v, stands for volume. I'm going to persist a directory inside this container. I'm actually going to map from my current directory, this Absolute Beginner's Guide to Docker directory. I'm going to map that to /code inside the container. And I'm going to run a container based off of the Python image. And then I'm going to run bash. So before with Postgres, we ran the container and then we did a Docker exec to run a command inside that container. Here I'm kind of doing it all in one step. I'm going to run a new container from the Python image and I'm going to run bash inside of it. So I'm now running a container based off of that Python image. It's running bash in there. And here, if I do Python, you can see I do, in fact, have Python and I can run it. I mentioned also that I mapped my local directory on my host machine to /code inside the container. So if I cd to /code, I do an ls. Here you can see that same README file and Docker Compose file that exists on my host machine, right? And so here I could go ahead and create a Python file, if I can remember how to write hello world in Python. If I have that go to app.py, there we go. You can see I now have a file that just has print hello world in it, and I can run, that's a valid Python file, so I can run that file and actually run my Python code, right? Okay, let's do, now some of you may have been thinking, okay, well that's great, but I don't want to do all my development using echo statements. That doesn't seem cool to me. I totally get you there. Now you could, if this container happened to have like Vim or Emacs or something like that in it, you could actually do development that way using a command line text editor like that. I mean, I don't know about all of you. I'm not really a Vim person. I'm definitely not an Emacs person. If you are, bless you, but I'm not. I want to use my own code editor, my own tooling, right? So let's do another example. This time let's do Ruby though. I'm going to do the same kind of thing. I'm going to do --rm, so it'll go away, -it so that I can interact with it. I'm going to map my local directory to /code inside the container. This time I'm going to run a container based off of the Ruby image, and I'm also going to run bash. So if I do ruby -version, you can see I have Ruby here inside this container. I'm going to go to the /code directory. You can see I still have the same files. I have the app.py because I did the thing where I mapped a directory inside the container to a local directory on my host machine. So I've got persisted. But at this time, instead of going and making a file using the command line, let's come over here in writer and let's make an app.rb, a Ruby file. And I also don't code in Ruby, but I can write hello world in Ruby. So if we come over here, you can see we have our app.rb file. And if I go ahead and run that, we now have Ruby code executing inside a container. Okay, let's come back. Let's come back here for a minute. So we talked about a bunch of different things. The main thing that we talked about is those 3 different types of containers that you can run in a development environment. The first type we talked about is a container that spins up and does a thing and goes away. The second type we talked about is one that spins up and runs some service indefinitely and just kind of sits over by the side. Think databases, message brokers, web servers, stuff like that. We talked about Docker Compose with that a little bit, so you can spin up a bunch of those really easily. And then the last thing we talked about, last type of container we talked about was containers that are running dev tools. The examples we used were writing Python and Ruby code, but there are other examples of that as well. Okay, so in any good presentation, you're supposed to have a call to action, right? Like you as an attendee, what are you going to go do based on the information that was presented here? So I don't know what you're going to go do, but I have a couple of suggestions of things you could do. You don't have to do any of these if you already have an idea of what you're going to do to continue your Docker journey. Go ahead and do that. If you're not sure yet, here are some possible next steps you could take. So a next step that you could take is you could go and try to write some code in a language that you're familiar with, but do it inside of a container. So for example, if you are a Python developer, you could go run Python inside a container and write some code in there. It doesn't have to be like big giant code. You could write hello world or something like that, but try doing it inside, running that code inside of a container in a language that you're already familiar with. That's one thing you could do if you want to. Another thing you could do is you could go run some code inside a container in a language that you're not familiar with. So say you always wanted to learn Haskell or F# or something like that. But it was cumbersome to install it. Maybe they didn't have an installer for your operating system, or maybe you were worried it was going to mess up some of your settings on your dev machine or something like that. You could go and try running that inside of a container. Again, you just write a hello world or something easy, but do it in a language that you've always thought about learning, but you have never gotten around to. That's another thing you could do. Another thing you could do is you could go to Docker Hub and go see if there is an external dependency that your code has. Either this could be work code or a personal project perhaps. That has an external dependency. By external dependency, I mean something like a database or a message broker or something like that. Just go to Docker Hub and see if there's a containerized version of that. There probably is. That could be a thing you could do. If you want to get a little more ambitious, you could actually try running that thing. So if you write code that depends on SQL Server, let's say, you could go to Docker Hub and see if there is a SQL Server image. Spoiler alert, there is. You can run SQL Server on Linux. You can run SQL Server on Linux in a Docker container if you want. So for this one, you could try going and actually running that external dependency that you're familiar with. You can set up the ports so that you can interact with it using your normal tooling, like to talk to a database or something like that. But instead of talking to the copy of your database or whatever external dependency you have that's installed locally, try talking to the one that's running inside of a container. That's a thing you could do. Maybe you've always wanted to play with RabbitMQ or Kafka or Influx or something like that, but you have never gotten around to it. Again, you'd have to go and install it, and maybe you'd mess stuff up, and you'd have to remember to uninstall it when you were done. Go try to run one of those things inside a Docker container, and just play with it a little bit. And finally, at the very least, just go install Docker and hang out with NeonCat. You can always do that. Just to finish up, a couple maybe useful links. Again, a link to the slides if you'd like to go do that. If you'd like to go go through these at your own pace. I have a small GitHub repo that has like the Docker compose file, and it has some links to the slides as well. That's that second link there if you are interested in that. If you want the notes that I was using as I was going through the command line stuff, all the different commands I was running, in case you were wondering, I did not have all of those memorized off of the top of my head. I have a cheat sheet over here on the side. That's the third link there. If you liked that whole, I'm going to go run hello world in programming languages that I don't have installed on my local machine using Docker, I have a gist where I have, I don't know, 7 or 8 different hello worlds in different languages, all using Docker. If you're super into using development tools in Docker, I have a friend, he works on a project where they implement common algorithms in a bunch of different programming languages, like 100 or 100 plus. And as you can imagine, having the development tools for 100 plus languages all installed on a machine is a little bit challenging. So they use Docker to run all the development tools for this project. So if that sounds cool, he wrote a blog post on it and he has links to the GitHub repo and stuff there. Finally, I mentioned that I work for a company called Immersion. We happen to do mob programming there. If you're not familiar with mob programming, it's kind of like pair programming, except the whole team does it. We also do things like test-driven development and continuous delivery and stuff like that. We have a guest mobber program, so you can go and sign up, and you can come and just code with us for a couple hours if you want to. A lot of people are interested in mob programming and some of the other practices that we do, but it can be challenging to actually institute that where you work. If you want to come see how some of those kinds of things work, feel free to come sign up with us. It's fine if you have tons of programming experience. It's fine if you don't know how to code at all. We're happy to mob with you on either end of those spectrums, either end of that spectrum. We do use Docker a little bit. We probably won't be writing Docker compose files all day or anything like that, but we do use Docker a little bit. Anyway, so if that sounds interesting to you, go sign up for that. And that is all that I have. Thank you so much for attending. Hopefully this was useful. Go out and do some cool Docker stuff.
Okay. Thanks, John. That was really excellent. We actually had over 500 people join the stream, so that's kind of like
Wow.
a blockbuster. Thank you. Thank everybody. Let's get to some questions because some folks had some really good ones.
Sure.
One of the first questions that actually came up in the stream was, can you use a different Linux distribution inside the container that's different from the host Linux kernel operating system?
So this is going to expose my Linux ignorance here. You can use different distros. So like there's a Ubuntu Docker image, for example. You may have seen it. I think in the Hello World example, it outputs the command to run Ubuntu. You can run different distros. My understanding of how it works is that it does all still use the same kernel that's on that virtual machine, but you can run different distros. So if Ubuntu, or I guess CentOS isn't a thing anymore, is it? That's too bad. But anyway, if you have a distro of choice, there's probably a Docker image, right?
Yeah, I know from my personal experience just using Docker images, I know .NET has like an Alpine, base image, and then also has an Ubuntu one, and they have drastically different sizes. So they all seem to work for me. So
Yeah.
I have the same experience you do.
Yeah, for the Alpine versus Ubuntu ones, usually it's what extra tools are installed. In my experience.
Yep. Another good question is, how does a .NET application access environment variables from the container environment? Because you actually went through the process of setting up environment variables for that Postgres container, but how would a .NET application access those environment variables?
Oh, that's a great question. There is stuff built into the .NET base class libraries to directly access environment variables. The way I've done it usually for a .NET application running in a Docker container is with configuration builder. So the configuration builder, if you're not familiar with it, it's a .NET Core thing. You can use it in .NET Framework also, but it's a .NET Core thing that lets you get your configuration from various different sources. Like they have a built-in way to get configuration values from JSON or from XML. There's also one for environment variables,
Hmm.
and you can set, the order of importance in those. That'd be a great presentation for someone smarter than me to give sometime, probably. Configuration builder stuff.
You're very smart, John. Not to grow your ego, but you're a very smart guy. So, but it's interesting too. Like I know in Rider, if you use that services window, you can definitely see the environment variables within a particular running container. So that's always like a good feature. Not to
Yeah.
plug our product, but
Yeah,
yeah.
I didn't show the Docker stuff in Writer very much, but
Mhm.
yeah, that would, if people are interested in more Docker stuff, that might be an interesting presentation to do sometime too.
Yeah. It's interesting. You kind of went through certain images, and this is an absolute beginner's guide to Docker. But a personal question for you is, what are your go-to images that you think developers would benefit most when kind of setting up their application, or maybe just test driving, um, Docker itself?
For me at least anyway, like for work, the stuff that I use every day is whatever database my code uses. If I can run that in Docker, that's great, because then I don't have to have, full blown SQL Server install on my dev machine, always taking up 12 gigs of RAM or whatever. I can, it's easy to spin it up and then spin it down when I don't need it. Any other dependencies? We happen to use Redis and Influx.
Mm-hmm.
Um, we also use, so we have, depending on your definition of microservices, we have a microservices architecture. We have more than one thing that runs that serves up web stuff, right? In production, then we have a load balancer that handles all of that and does route-based path-based routing. That's what I was thinking of, to different parts of the application and stuff. To kind of simulate that locally, we use Nginx running in a Docker container to kind of fill that same role of load balancer. So yeah, one of the nice things about, so those are some of the things that I use frequently.
Mm-hmm.
One of the nice things and challenging things about Docker is you can do so many different things that it really depends on your context what will be most valuable to you. But those are the things that I use a lot.
Yeah, I mean, I guess a follow-up question to that, which kind of relates, but one of our viewers asked, "What's the benefit of actually running these services inside of a container rather than just having them all installed on your local machine?"
So for me, there are a couple possible advantages, and it'll depend on your context if which of them are advantages for you, and if they're worth it to you over installing it locally. Some of the advantages that I've had are the one that I just mentioned. Like I don't want SQL Server running all the time on my machine, always taking up however much RAM it decides to take up. You can configure that, but sometimes it's nice to just say, no, SQL Server, you're not running right now. I want all my RAM back.
Yeah.
So the ability to quickly and easily turn those things on and off, right? Not that you can't do that for installed ones, but Docker does make it relatively easy. So that's one. Another one is like for it, it makes it really easy for like a database. If you want to say, well, just take me back to a nice clean state, with whatever my normal schema is, whatever my normal data is, you can, because it's so easy to just wipe out, the whole file system and all those volumes and stuff. It's really easy to get back to a default state if you have some scripts that will, if you have like a database migration mechanism that will rebuild that schema for you and stuff like that.
Mhm.
That can be super easy. Also, the third possible advantage that I can think of is when you have a new developer on your team and they need to have Nginx and SQL Server and Influx and Grafana and what was the other one, Redis. They need to have all of those set up, all of those configured properly. You could install all of those. You could maybe even have some kind of setup script that installs those all locally and configures them. could do that. Uh, or you could have some Docker compose files. That's what we do. We have a couple Docker compose files. And so a new developer just needs to pull the code and run Docker compose up in some places, and they have most of the infrastructure that they need.
Yeah, I think for me personally, that's one of my favorite things of just being able to, codify your application infrastructure. So I'm not sure if you've ever tried Project Tie, which is a project from Microsoft, but
Mm-mm.
it's kind of also does that kind of stuff where it can just spin up your whole solution, and it's really tied to .NET, which is really, really cool. Um, the obvious question is folks maybe start getting into Docker and building their own images, but what's your process in terms of actually updating images once you've made changes?
Oh yeah, so like in this presentation, we didn't really talk about making your own images, but you totally can, and you can put whatever you want in there.
Hmm.
Like you can put your own application or your own tools or whatever. So we run where I work now. We do run a couple of things in Docker, and so we have the code for that thing in a Git repo, and then we have a build pipeline hooked up to it, so that when we make changes, it automatically goes off. Um, and so it will build the code, and it will actually build the Docker image. And then for the particular stuff that we do, then it's not like it's proprietary, language assessment stuff. So we don't want that on Docker Hub necessarily. So we do run an internal private Docker registry, and so we publish our image to there. And then we happen to use Azure and Azure DevOps, and so we just have a build pipeline in Azure DevOps for that. And we use the built-in Azure DevOps artifact repository stuff. And then we in Azure you can have an app service that will run containers for you, and so that's where we run it. We could in the past I have done like running containers in Kubernetes and stuff like that. You can't do that, but yeah. So we have a whole build pipeline and everything for our building our images and stuff.
Yeah, we actually have a viewer right now, Diego, who says this is more of a comment. He says, "I'm a Linux user, OpenSUSE, and it was hard to configure PostgreSQL, MongoDB, but when I found Docker images of both, I found love, heart emoji." So I think that's kind of for me personally with the .NET Core and .NET 5 evolution. It's just nice to see .NET kind of embrace these other ecosystems strengths and kind of use it to our advantage. So
Yeah. Oh,
um,
that comment did make me think of one other possible advantage for putting some of your stuff in Docker. Like you mentioned .NET Core. .NET Core is good about having like multiple versions run side by side,
mhm,
but some other languages are not so good at that, and like they'll stomp on each other and do bad things. You can
mhm,
run some of those tools in Docker containers and have a very specific version. Also, if like your application needs very specific versions of other external libraries or whatever, that's
mhm.
a great way to like lock down those versions. Say, I'm only going to use this version.
Yeah, I know. Like when I was experimenting with a graph database Neo4j, they didn't have multi-tenancy at the time, so you couldn't actually run multiple versions of the data or multiple instances of your database. So containerizing each instance that you want to run of that graph database is kind of a perfect solution in that scenario. So
Yeah, that's
just to kind of echo
another
what
great
you were
example.
saying. This is always a common question. You could probably say this in one word, but Dinesh asks, "Can you use Windows images on a Linux machine?"
No,
Yeah,
not as far as I know.
yeah.
There might be some blog post of somebody somewhere who figured out how to make it work, run like a Windows VM and hook it up somehow. But as far as I know, you can't do that.
Yeah, I think a lot of users throughout this talk were kind of asking a similar question. Can you mix and match a container's operating system? Uh, can that be different than the host operating system? And in general, no, that's not necessarily how Docker works. Docker containers talk to the host operating system, and they need to match on some certain levels. So
Yeah.
Sorry.
That said, depending on like your exact virtualization technology and your exact version of Windows, you can run Docker inside of a VM. So like
Mhm.
theoretically, you could run Linux and then run a Windows VM and then run Dockers in there and run Windows containers in there if you got all of the things to align just right. But
Yeah, I wouldn't, I would hope the DevOps person that you're talking to doesn't, has a sense and says, "Oh, no, this is I'm not doing that work."
yeah, yeah,
But, yeah, I think that's it, for all the questions. Again, John, I wanna thank you, and I wanna thank everybody, who's joined. Hi, John's son.
including my son here who just walked in.
You can wave too.
You want to say hi?
Hi there.
This is
Everybody say
Maxwell. He's my 7-year-old.
what's his name?
Maxwell.
Oh, everybody say hi to Maxwell, in the chat. So, again, thank you, John. Thanks everybody for joining. Today was kind of a great session. Just as a reminder, this talk was recorded and will be on JetBrains TV. So, please give a like when that video shows up. Make sure to subscribe and hit the notification icon to get any new videos that are coming up. So you can kind of see the chat just saying, "Hey, Max." So yeah, thanks everybody, and thanks, John. Talk to you
Yeah.
later.
Thank you.
Bye.